off. So as I say, I've been at Microsoft for a couple of years now. I actually joined Xamarin just before the acquisition. So prior to that, I was at Nokia for 10 years, working on a variety of music applications, including one some of you may be familiar with, mixed radio. So a few nods there, yeah. So yeah, it was just saying to Tom, it was a sad day when we found out that that was shutting down. But yeah, some happy memories working at that company. And on the back of that, we were working with Xamarin really closely on the iOS and Android clients for mixed radio, which thankfully gave me the opportunity to join the company. And so yeah, on the back of that, I've now been acquired by Microsoft twice now. So. So yes, so some more details if you're interested in getting in touch. So yeah, I'm going to be talking about Xamarin Forms. So how many of you are familiar with it and have used it at all? So a few hands. So good. So I'm going to give a bit of a background to it because I've assumed that not every one of you will be familiar with it or have used it at all. And there's a lot of parallels with it and React Native. So I thought it'd be good to talk about some of those and just talk about exactly what Xamarin Forms is. Now there's often some misconceptions about Xamarin and Xamarin Forms, and some people conflate the two and think they're the same thing. They're very, very different, and so I think it's important to understand what that distinction is. So Xamarin Forms is a cross-platform framework which allows you to develop everything from the UI down using .NET code and XAML markup. So that's it in a nutshell. But essentially it builds on top of the Xamarin platform. So the Xamarin platform allows you to write cross-platform applications, but natively using the native development tools. So you'd be using Xcode for designing the UI, so interface builder, and you'd be writing your Android UI using XML markup language. But however, you'd be able to have a huge amount of shared code using .NET and C#. So for any developers familiar with .NET and C#, it's a really good option for sharing a huge amount of code. However, as I say, you still have to develop the UI using the native tools. So Xamarin Forms builds on top of that and allows you to abstract away the UI layer in a similar way to React Native, in that it abstracts all of the UI controls and layout and provides its own subset of controls which are common to all of those platforms, and exposes the properties and methods which then drill down into the native APIs and controls. So you're still able to utilize the native controls on an application, so you get the same kind of performance and look and feel of a native application, but you're able to define the UI using a common shared markup language. So in the case of Xamarin Forms, we use XAML, which is very similar to the XAML which some of you may be familiar with WPF and UWP, but there's some subtle differences which when you first pick it up you think, okay, where's the stack layout, for instance, or the stack panel rather. But that's being addressed as there's some work being done to standardize the XAML markup language across all of the Microsoft technology stack. So that's quite important to understand that. So yeah, that's in a nutshell the actual Xamarin Forms abstraction there. As I say, it abstracts across iOS and Android and UWP. So one thing to consider is, when do you want to use Xamarin Forms and when do you want to go Xamarin Native? So typically I deal with customers, the customers I deal with use Xamarin Forms almost exclusively. And the reason for that the customers I deal with are typically enterprise customers. They're developing line of business applications, so companies like British Airways, British Gas, the NHS, large enterprises, and they just want to have functionality is key. The look and feel of the application isn't so important, so the finesse, we're not talking about commercial applications where you have to be pixel perfect. We're talking about applications where it's essentially form filling. And that's typically been the decision the distinction between whether you want to go with forms or not. It's whether you really need to be absolutely, you have a design. If you have a design team who want absolutely every pixel to be modified and to look exactly as is, then perhaps you want to go with a native approach where you have that level of control. Other elements to consider. There's this concept of custom renderers, which Xamarin Forms allows you to still drill down into the base, the native APIs, and cool down into the base native APIs. But once you find that you're having to create too many of these, once you hit a threshold point where you're creating many custom renderers, at that point you may think, okay, that maybe Forms isn't the way to go. So we have sometimes hit that issue. So you get quite a lot of tools with Xamarin Forms, and you can create incredibly powerful applications using nothing but what you get out of the box with the Forms API. Many layout controls, navigation. We provide a two-way binding framework, which allows you to follow the MVVM pattern. So people familiar with MVVM at all? Yeah. Really powerful pattern for being able to abstract away your models and to define visual behaviour in a common method, which you can then expose in the UI. So then moving on, just because I wanted to talk about, this is just giving you a high-level overview. I want to then move on to cover some of the new things that have been added over the last year. So we've provided a number of animation frameworks which are really powerful. You can use the async and await pattern to apply translations and rotation and scaling, all that kind of stuff. And you can see that it's really readable format. And to make your animations in parallel, you just simply have to use. You can use the await async pattern. So if you don't await a call, an animation call, then it will run in parallel. And if you want them to run in sequence, then you just await it, and then it will happen one after another. Moving on. So as I said, one of the important things to understand about Xamarin Forms is it is providing you the common controls across all platforms. So it will only expose controls which are common to every platform. So that essentially means you're getting the lowest common denominator. And I think it's fair to say that React Native suffers the same kind of issue, where you don't have access to all of the same controls natively that you would if you're developing a native application. So so there are a number of controls which, as an iOS developer, you would take for granted that you'd have access to, and Android and so on. But there's a Venn diagram which this nicely illustrates, where the exposed controls, of which there are many. So it's fair to say that the subset is fairly wide and covers a nice surface area that you have access to, and it generally provides everything you need out of the box. But yes, it's important to be aware that there is that periphery which you don't have access to, or didn't until recently. So there are a few ways that issue is addressed. For instance, we have the concept of on-platform, where you can make tweaks to an individual element depending on what platform the application is running on. So for instance, on iOS you may want elements to be slightly wider or have a higher margin, and you can use the on-platform keyword for that. Then there's this concept of custom renderers, which I touched on. Then there's the concept of behaviors, which allows you to apply functionality to elements which will apply across all instances of the application, so all implementations. So essentially they're a cross-platform extension. So for example, any interactions with an element, you can extend the behavior without trying to use the same term. So you can extend the behaviour of an element using behaviours, and there's essentially a collection of behaviours you can assign to any individual control and affect how it works. Then if you need to be able to drill down and interact with, for example, a button has, as I said before, will only expose properties which are common to all platforms. However, if there's a specific property which is on a platform, so on Android there's a shadow property, for example, or a border width property, which you know exists within that underlying control, you can use an effect to drill down and interact with that. So that's just one of the ways that Forms allows you to still have access to properties and methods, even though it's kind of abstracted away. And finally, you can do native embedding, which means that you can embed native controls. So if you have an instance of an iOS control, you can actually drop that into your Forms application and use it as is. So moving on, I just wanted to touch on the things that have been done since then. So what I've just covered is kind of the high-level overview of what you had out of Xamarin Forms, out of the box. A lot of work has been done on performance because there's been a huge, one of the biggest complaints has been the performance on Android. So on iOS it hasn't been too bad, but for anyone who's developed with Android, you may be aware that it really doesn't like having many layered elements. So as soon as you have a deeply nested hierarchy, visual hierarchy, then performance is greatly impacted. And so that has been an issue by the nature that Xamarin Forms lays out controls, and you will have a deeply nested hierarchy on the native side. So when it actually generates that the native hierarchy of elements, they will be quite deep. So one of the things that's been done is to do layout compression, which is to effectively compress that hierarchy during the compile process. Bottom tabs, this is a funny one because it's something that almost every company I've worked with has said, we want our Android app to look like iOS, so we want tabs at the bottom, and that's all, but they'll be using Forms, and we say, okay, well, we'll have to write a custom renderer for that. So that's always been the solution until now. So as of Forms 3.2, actually, we've now introduced a simple statement where you can just set bottom tabs to true, which is ridiculously easy compared to how hard it was just a few months ago. So yeah, that's fun. Flex layout for any web developers, you may be familiar with flex layout, so that's just an extra way of layout controls that we've introduced in Forms. So right to left support, that's another common one I have because we deal with companies who want to support multiple languages, including languages which require right to left support. So that would previously require a custom renderer, which is a huge amount of effort and kind of defeats the purpose of and the beauty of Forms, which is that it is really high level. And so now we just have a simple set to true is right to left. So stuff that you may perhaps take for granted in some languages, we now have to provide those features. Style sheets as well. So this is an interesting one. There's obviously catering a lot for web developers here. So there's a lot of effort to kind of beckon web developers onto the Xamarin side. So we now support CSS as a way to style and change, the color and look and feel and layout of elements. So that works on top of the typical styling which you'd normally use, which is using resource dictionaries. So this works in companion with resource dictionaries. So you can effectively it overrides the layout. So you could have a web designer provide you the CSS, which completely changes the look of your application. And then there's Visual State Manager, which I know I've been asked a few times by developers. In fact, Colin, I remember not too long ago you asked me if Forms supports it. Well, now it does. So Visual State Manager is a feature which anyone who's used WPF would be familiar with and fond of, which essentially allows you to apply animations and constraints and change the layout of the application based off certain states. In fact, you can change more than just layout. You can change visual properties, you can change opacities, and all sorts of elements of a control based off the state that you set the application in. For instance, orientation or hover state or that kind of thing. So you can basically have a whole set of rules which say, okay, when I'm in this state, I want to apply an extra margin to this, or I want to flash this control when the mouse is over it, or when I press it. So it's very flexible, and one of the major beauties is that it's defined in markup. So rather than previously where you'd have to define behavior like that in code, you can do this entirely in Xamarin. So yeah, so that's a really cool feature. So we're moving on. So how are we doing for typing? So now I'm going to be covering a couple of things which are in the pipeline, which haven't even yet been announced. They're not even officially on the roadmap. But I thought it'd be good to cover, because this isn't like private stuff. This is stuff we have actually announced on GitHub, and we're looking to get feedback from you users to see if there's any demand for this. We think there is. There's some useful and intriguing elements to this, which I think may be of use. So there's two things I wanted to cover, which is this new Forms shell spec and Forms drawing API. And the two go hand in hand, but I'll cover the shell spec first. So it's quite a tricky one to explain at a high level. I've used this quote, which is from Jason Smith, the lead developer on Xamarin Forms. But I'll try and give you my explanation of it. It's essentially an abstraction layer on top of Xamarin Forms. So it uses the Xamarin Forms controls, but it allows you to architect your application at a high level. And lay out how all of the elements of your application pull together, the actual hierarchy of your application. So I'll show you an example of that, and I'll show you in code, because it may, I've tried numerous ways of trying to describe this, and essentially is, if you imagine you have multiple pages of your application, and you don't know how best to lay them out, whether you have them in tabs, or you have them in a flyout, or what shell does, it allows you to define in markup how you wish to lay out those all of those individual pages. The tab structure, the flyout structure, and I'll show you the markup, and you can then you get an idea of how it works. But it's quite intriguing. It's quite an interesting way to go. But you can see here's an example of here we have two content pages. So if you're familiar with the content page, it's literally just a page of data, something you would navigate to. With the shell spec, you reference each one of those pages, and it will work out. So it's an opinionated way to generate the visual architecture of your application. So I'll show you that. In fact, I'll pull out the demo. Bring it up. Is that readable?
Yeah.
So you can see here we have a flyout header. In fact, I'll show you the application first. I think that would probably be preferable. Then you can. Some fun layout issues here. So this app's available on GitHub, so you can look at this in your own time and try and get a better feel if I don't manage to completely convey how this is this works. So we have three main content pages which are contained within the shell. So the shell is the root of your application. So if I go back to the code, you can if I show you the code here, we have a main application which is here. So this app's called gastropod, and it creates a shell, which is defined in this SAML here. And that contains all of the pages of your application. So it encompasses all of the pages. So it acts as that's the word shell is come from. It's the basic structure, the shell of your application, is defined in this markup. So whereas typically you'd lay out your application with navigations from page to page, all of that kind of logic of how to navigate around your application is contained within this one page. So hopefully that makes a bit more sense then. So you can see here, we've in this case, it's all based off how you embed and the hierarchy you define for in your markup of how you reference each element. So there's a really good article, there's a GitHub page which describes this. So one of the key things about this is the first implementation, which there's a prototype of, which I've just shown you here, is using material design. But that will work on iOS as well. And the reason, once this is complete, is that we'll be using a new UI framework. So whereas previously we would all controls would be using the native controls. So I previously mentioned how every control in Xamarin Forms drills down and creates a native instance of the control it's representing. With Shell and this new drawing spec, it will be using a very similar pattern to Flutter. So I don't know if any of you are familiar with how Flutter works, but all of the controls it creates, it's not actually creating the native controls, it's not creating a native button, it's actually drawing all the elements. So for instance, a button is rendered in markup using vectors and drawing code. And so there's a number of key benefits to that, which we see that you can really optimize, particularly Android, because as I said, that's been one of the biggest issues for us is performance on Android. But also this gives you the flexibility to define exactly your look and feel of your application without having to write any custom renderers at all. All of the UI would be defined in markup, so very similar to the old days in WPF, where we were able to define vectors, and in this case you'd have a visual hierarchy defined in markup, in XAML. So you'd have a button defined as a drawing, which contains a rounded rectangle, an ellipse, and text. And that's essentially all a material design button is. It's literally just those three elements overlaid, and then you can apply animations and effects to any one of those elements, because they're all addressable as an individual element. So you can do the whole ripple effect and that kind of stuff, and that would be, you'd get that for free out of the toolbox, out of the shell spec toolbox. So as I said, I've provided a link to the GitHub pages for both of these specs. Feel free to reach out and feedback if any of you find this useful. And with that, I think I was going to open for questions, but I think we're holding that till after. So.
Yeah, well actually, does anyone got any burning questions they've got to ask?
Yeah, feel free.
You normally write the entire app UI using Xamarin Forms, or like for specific parts of it?
Typically, to be honest with you, we would typically write the entire application in Forms, but we've had many customers recently who've gone down the native route. Now, so a good example is Sky. So we were working with Sky last year, and they'd written their entire application in Forms, and they wanted to test out Xamarin Forms. So with the latest version in 3.0, you can now create native controls, so you can actually embed forms within a native application. So previously you could do it the other way around, so now you can do it both ways. So you can have native code in a Forms application, but you can also have Forms code in a native application. So it really is very flexible. Yeah.
Just on that last point you were
Yeah.
on about the button, you said the buttons are made up of basically the components that button is made up of.
Yeah.
Does that mean that with future OS updates you won't get the new variations of
Yeah,
those
so
buttons for free?
That's often been a concern, like for instance with Flutter, and I guess that's entirely down to the developers having to keep in sync with the API. But that's typically the case anyway, because I've heard this argument, and the counter argument is, well, you have to support every update anyway, so yeah, okay, this is another extra detail to worry about, but the benefits outweigh, the issues with having to do that.
The flip side as well,
Yeah.
with Flutter is like the fact that you get material look and feel like all the way back on the old Android version,
Yes.
which didn't support it. So
Mhm.
I mean, you can do that with the support library and stuff, but it kind of works both ways. You're right, you don't get the new stuff, but you have to backport a bunch of loads of stuff.
And if you have a really specific look and feel you want for the application across all platforms, well, you get that for free with this, and there's no having to, okay, well, how do I get it to look like this on iOS? Well, it will already look like that on iOS. So yeah, I think there's definitely something to be said for it, but it depends on the level of interest.
With the drawing API and the kind of show the composable button there, I mean, is basically everything, like every component going to be drawn, or is it going to be like a mix and match? So it'll be like
I guess it would be
progress bar won't be and the button will be. Or
yeah, so potentially it will be an incremental thing. I can't imagine every single control, but I guess that's how Flutter works. So yeah, I mean there is only a finite number of controls, so I guess yeah, that's quite possible that everything. You would get everything out of the box, but yeah, it's really going to be down to demand and interest, because currently the only person working on it is Jason Smith in his spare time, so, effectively, yeah, but yes, he's quite passionate about this and he thinks there's definitely some mileage in it, but yeah. Hi.
Hi, the shell is quite interesting. So my background is mainly Android, and they recently announced this navigation WYSIWYG where you can visualize your apps. Is it similar to that, whereby you can actually use the shell to describe your app visually, as in like how the activities would link or how the screen controls would link?
I guess the potential is that you could, so you mean to actually draw
Draw the lines.
yeah, so draw the lines again. I guess that's the natural follow-on step from that, because I think the intention is to be able to have a wizard which you say, all right, I want these pages and this kind of hierarchy. So I guess the wizard would be this kind of visual drawing. Yeah, yeah. So it would effectively be a storyboard, I guess. But this is just a way to define it in markup. So yeah, yes, there could well be a UI for that.
That's the only thing that makes you want to go to a single activity, which is kind of the main driver of the Android one, is that I get this nice description of my app in a visual way. I think that's a great way to onboard me.
Right. Yeah.
But yeah, something to think about.
Yeah.
Well, thanks, Ben.
Okay.
Cheers. We'll take